Welcome. Thank you. So today we're going to go through cyclic quadrilaterals. So we haven't done all our proofs for circle theorems. We may do the other two at the end of the lesson. Where we're up to, properties of cyclic quadrilaterals. So first we're just going to remember a quadrilateral is any shape with four sides. Okay, so four straight sides. So, you know, that's a quadrilateral, a square is a quadrilateral, or so is a rectangle. So is, we'll try and draw something absurd here. So is this shape. Okay, it's got four sides, it's quadrilateral. And what do all internal angles of a quadrilateral add up to? 360, okay? How do we know that? How do we know that? It's because it's a full revolution, because it's a full circle. This is the simplest way. Alright, is every single quadrilateral that you can possibly draw is made up of two triangles. And we know internal angles in a triangle are 180. So therefore internal angles within any quadrilateral are going to be 360 degrees. Right, so that's a pretty easy extension of angle sum of a triangle. When we're talking about a cyclic quadrilateral, it is a quadrilateral that's drawn within the circle, and all vertices are on the outside of the circle. Okay? So all points are on the outside of the circle, and the shape lies completely within the circle. Now, this has the special property that opposite angles are supplementary. Okay, so this plus this is going to be 180. And this plus this is also going to be 180. If it satisfies that property, okay, if we have one pair of opposite angles that are supplementary, it means the other one has to be as well by elimination. So if we have one pair of angles that are supplementary, it means it's a cyclic quadrilateral, which means a circle can be drawn around the outside of it, okay, showing three equal points. So we're going to prove the theorem, and we're just going to start with I'll start with a circle, and I'll just draw roughly a square. All right, and we've got some point of origin here in the middle, point O. So what we're going to do, guys, we're going through the proof that cyclic quadrilaterals have opposite angles that are supplementary. Let's go through that proof. So first what I'm going to do is I'm going to draw these lines here. Okay, and I'm going to go through and label everything. We've got A, B, C, D, and O. And I'll rub this out so we can do the proof alongside. So let's let angle back be alpha. Okay, so if this angle's alpha, therefore, angle BOC, this angle in here, is going to be 2 alpha. Alright, the angle at the center is always double the angle on the outside. So we've got 2 alpha here. And so that's going to be 2 alpha because of angle at center. Then, O is the center of the circle. Point O. Yep. That's the center point of origin. Then let's introduce you to some normal, some new terminology. We're going to call it the reflex of angle BOC. All right. So I've described this is angle BOC. It's this angle inside here. So that's point O. So that means the reflex of it is going to be angle BOC, but on the other side. We don't have another way we can describe that. Okay, other than it's the reflex angle opposite BOC. So the reflex of angle BOC, this big angle here, is going to be 360 take 2 alpha because of angles at a point. All right. So what we've got here, if we know if this angle is 2 alpha, okay, this angle is alpha, and we've got this angle is 360 take away 2 alpha. Now we're just going to use that same rule again, that the angle at the center is twice the angle on the outside. And so it can be a little bit confusing because normally we're dealing with it in that circumstance where we can see it clearly double, but the rule still applies here. This angle is going to be half of the reflex angle here. All right? So it's like this. If this is A, this is 2A, that's one way of representing it. But if this is A, then this angle here is also 2A. So that's what we're doing. We're just doing the reflex of it. All right, we've got here's A, this is 2A. So therefore this angle, half of that has to be this angle. Twice this angle is going to be that interior angle. So therefore angle BDC is going to be half of 360 take 2 alpha. And that's because of our first rule, angles at center. Angle at center is twice the angle at the exterior. All right, and half times 360 take 2 alpha is 180 take alpha. And so then we've got opposite angles, so angle BAC plus angle BDC is going to be 180 take alpha plus alpha, 180. And so these two angles, regardless of the shape of the quadrilateral, okay, regardless of the angles, sizes, if it's within a circle, then the opposite interior angles are going to be supplementary. Let's do our examples. So flip the page. Okay, so here, in this shape here, let's have a look. We've got we've got two cyclic quadrilaterals, okay? We've got A, D, E, F. That's a cyclic quadrilateral because we've got these 4 points on the outside. And then we've got this other one, which is A, B, E, F, okay? And so all opposite internal angles are going to satisfy that rule we said. So that means let's solve angle X straight away, okay? We're going to have X plus 104 is 180 because opposite angles in a cyclic quadrilateral are supplementary. So we're just going to reference that as cyclic quadrilateral. So we've got X is 76, okay? And we've got two ways we could solve for Y. We could say the same rule because FADE is also a cyclic quadrilateral where they are opposite angles. Alright? But see how these things are linked, okay? Is that X and Y subtend the same arc, don't they? They're in the same relative position in those two arcs. So we're going to have Y is 76 because we could say angle sub. Alright, or we could reference the same point again, the opposite angles in a cyclic quadrilateral are equal. Now I haven't given you enough information here to find Z, so we'll just leave that for now and then fix that in the booklet. Okay, let's look at number 2. We've got some quadrilateral, and it's not drawn to scale because the angles are changing each time. Alright, so we're just, to answer this, I might just go through the first two. So we've got A, B, C, D. Okay, angle ABC, angle AE, I think I've messed them up. That should be there, that should be there. Angle ABC, this one here, is 110. And angle ACD is 80.
Mr. Royals.
angle ABC. If I do that though, angle ABC is going to be this angle here. So that's not very helpful. So
Yeah,
let's do it like this. Angle, we've got 110 and we've got 80. Alright? So is this a cyclic quadrilateral? We don't have enough information to suggest whether this is cyclic or not. What about in the next two circumstances? Angle BAC and angle CDB. Yeah, this one will work. So the answer to part A is there's not enough information. Hang on. Let's keep it as it is there. And so if we let's go to part B. I think I might have missed that part. Angle BAC is 65. BAC is 65, and angle CDB is 115. Okay, so we've got opposite angles here, and we just have to check, do they add to 180 degrees? Okay, 115 plus 65 adds to 180 degrees. Opposite angles are supplementary. We've got one pair, therefore yes, as opposite angles are supplementary. Okay, C. We've got angle BDC is equal to, so it doesn't tell us the value, angle BDC, let's call it theta, is equal to angle CAB. These two angles are equal. Is that enough to say it's cyclic? No, okay? The only time this would be true is if they were both 90. But we're not told they're 90, they could both be 27. Right? They could be any value really, so no. There's not enough information to declare them cyclic. Could be they are, if they're 90, but they're not. Not enough information. D. Angle ABD equals angle BDC equals angle DCA equals angle CAB equals angle CAB. All angles are equal. Alright, now we know, it's obviously not drawn to scale, but we know all angles must add up to 360, which means all angles are 90, which means opposite angles are supplementary. So yes, this is a square, isn't it? Or it could be a rectangle, but it can't be a rectangle because it's cyclic, it has to be a square. So yes, as again, opposite angles are going to be supplementary. Theta plus theta is one angle.
Wouldn't it be the same as C though, that's only in one circumstance?
Yeah, if we're not given lengths.
There's only one possible circumstance.
No, that's...
Oh no, rectangles can be cyclic. Yeah, rectangles can be cyclic. Yeah. Could be a square or a rectangle. Yeah, so you're right. Yeah. So how about A? Was there enough information in A? Or maybe I made a mistake there. Let's see. ABC is 110. No, that's that angle there, isn't it? And ACD, that angle is 150, is 80. Yeah, we do not have enough information there. Alright, so A, not enough information. B, yes. C, no. D, yes. Excellent. So, enough teaching. We're going to be going through the questions on cyclic quadrilaterals. So that's 22 through to 26 inclusive. That's our plan for today. Let's get